Well, hi, good morning from my shop here in Orillia, Ontario, Canada. But what I've got here is a radio that was made far, far away from here. This is a radio made by SABA. I think these are relatively rare in North America. I mean, I have seen SABA radios around, but not very many, in fact. And this particular radio is mine. I've had this for a long time. Back when I was working full-time in the mid-90s, one of my fellow employees showed up at my desk with this and said, "I hear you like old radios, here's one," and handed me this, which they were going to throw out. And rather than throw it out, they gave it to me. So I played it a couple of times soon after receiving it. So I know it worked. But you know, that was 20, I hate to even calculate it, I don't want to calculate it out, 20, 25 years ago. So really this radio almost certainly has not been switched on in 20 years. So we're going to kind of, I don't want to rush into this. I don't necessarily even want to restore it. I'm interested at this point in seeing how well it operates, if it operates at all, and learn a little more about it so I can make some wise choices. Because for sure, when I look in the back, at a glance it's just another radio, but a closer look, and there's some stuff in here I don't particularly recognize. Like, can you see this thing here? So I'm sure, what can it be? A coil, capacitor, resistor? I mean, it can't be much else other than that, but nevertheless I think this would be really interesting to look at, especially a little hard to see in the camera right now, but this very odd looking system for tuning the radio. Lots of potentially things done differently in this radio than others that I've seen before. It's a multi-band radio, does a regular standard broadcast band, and then it does two shortwave bands. And in the information I've looked at about this radio, the radio is claimed to be FM ready. Well, I have no idea what that means, and I suspect it came from the marketing department. Hey boys, can we just, can you put a jack on the back or something and claim it's FM ready? This was from 1950. 1950 FM in Europe, I don't know anything about. I understand there was an early version of FM with an early band assignment that was abandoned at some point, and that might have been in the 30s even, here in North America. I don't really know the history of FM until it really caught on. FM really only caught on after I showed up on the planet. So really nice radio. The cabinet is in beautiful condition, although it needs some there's been a lot of the coating here is frying. It's coming off in flakes, but I think I can probably make this look a lot better. Here's just a better look at it. You can see what's going on with it. But in terms of the seams and everything, it's beautiful. It's beautiful, very much so. It has a magic eye, which is kind of neat, and also very unusual to have knobs sticking out the side of the radio, especially one way at the back here. The engineers were too lazy, I guess, to try to arrange it onto the front, because putting it on the side is really kind of odd. Although from an operating point of view, when you're standing here, this is the tuning here, it's mainly built for somebody to stand just like I am. The plate is angled upward slightly, so at arm's length, maybe sitting down in a chair, this would be just perfect. You'd be looking at this and reaching out. It's quite comfortable to do this. So I'm gonna from here I'm gonna go over the schematic. I've got it on the computer. I'm just gonna show it to you on paper briefly. It's all in German, so I can't dwell on this for too long, but I did spend about an hour staring at this last night while my wife was watching Dancing with the Little Stars. So let's take a look at this schematic here. I'll put it on the screen. Oh, maybe I won't. Oh, I gotta make a little change here. Okay, so here's the schematic. The first thing the schematic screams out is, oh my god, this is really complicated. So let's decomplicate the schematic a little bit before we start looking more closely at it. So one of the things that makes it complicated is this stuff down here, which is just kind of blows your eye away. There's one here, there's one here. So these are tube-based diagrams they have stuck onto the main schematic for reference purposes. So you just see that stuff there, you just kind of take that off your eye. so you don't see it anymore. These things down here, you know, to be honest with you, I don't know what these are yet. I haven't figured it out. Probably related to switch and switch positions or something like that. Now, this is a switch position table, which I don't fully comprehend how this fits in with the radio. But I'm pretty sure that's what this is. These are the different bands. This is, for instance, this is a tape recorder or auxiliary input, long wave, middle wave, short wave, and then UKW, which my understanding is that stands for FM. So I don't know what's going on here. You'll see when I flip the control for selecting bands that there's more than 3 positions on the band selector. Yet, when we look at the schematic, it looks like there's only 3 bands, because here's the local oscillator. It appears to have 3 coils in it for 3 bands. 3 bands kind of fits what's on the glass plate, except for the FM ready part. So a little bit of confusion about how FM fits into this radio, if it does at all. I don't see how, but then, you know, it's all in German to me. So okay, so looking over the actual schematic now a little bit. So big transformer here, rectifier tube, AZ41, never heard of that. Okay, a couple of big filters here. This is a choke coil. This could be part of the speaker. I don't think so though, because I glanced at the speaker earlier. I saw only 2 wires going to it. So this is probably a separate choke. So and this is the B plus line around here. Okay, this is the B minus line, this heavied up black one. Is this the chassis too? I don't know offhand. Okay, so we take a look at the output. How are they driving the speaker? So it's a single tube. I guess you would call that Class A operation, I believe. There's the transformer. Let me see the speaker. Just 2 wires going to it. So exactly what this is, I don't know. It says 9 kilohertz something or other. I don't know what that is. Look, there's a little connection here. Oh, that's just back to the negative bus. So one side grounded to the negative bus. So I have an output tube, EL41. I never heard of it. I mean, I'm not that familiar with European tubes, but these aren't the usual tubes, I don't think. These are probably rare. They may not have North American equivalents. So turning on this radio runs the risk of wearing out one of these tubes and the radio being pretty much unplayable till I roll the dole out for a tube here, which I don't want to do. The object is not to spend money on this radio, not really. So you can see some switches up here. Okay, these are mind-blowing switches for me personally. I have a heck of a time trying to sort out what this is saying. You see these 2 are ganged together. It's probably the band switch. Boy, analyzing these kinds of things is really, really tough. So I only want to do that if I have to. And even if I have to, I still don't want to do it. So we're not going to do it now. So some a little bit unusual. Not really unusual, but look at all the switches in here. Switches all through here. How these are being switched, it must be part of the band switch, I guess. Maybe this table helps out. Maybe these table numbers refers to the schematic numbers up here. Maybe that's what's going on. So we could look and see, for instance, switch S4. Pick S4 should be open, open, open until you get to shortwave, then close, closed, and closed here. I think that's how you would read this table. Hopefully we don't need to. So there's a pile of coils affecting the antenna. Look, complex antenna circuitry here. Again, 1, 2, 3 bander. This feeds into the grid here through the tube and on out. Look, they've shielded the output of this tube here with a shielded wire. The local oscillator is working through this triode. This is a double tube here. It's working through this triode. Once this gets oscillating, you get an oscillating signal in the plate circuit here, but you'd also find it on the grid, of course. And look, they just extended the grid over to the other side of the tube, where the oscillations can then affect this part of the tube. So you're going to mix together the oscillator and the signal coming from the antenna. And if my understanding of this is correct, because this part of the tube anyway, is operating in a non-linear part of its characteristic curve, you end up with harmonics. And out comes a harmonic designed, or not designed, but intended to match the IF. The IF is over here. So this part, I don't know what this is. I looked at this for quite a while last night. I could not sort out what they were doing in here. But they're doing something. Something's going on here. I don't know what. Here we get to the first IF tube. You know, like these look like IF. I should talk a little more. These look like IF transformers, and I studied them thoroughly. I could not sort out what's going on here. I really couldn't. So I won't worry about it now. I'll worry about it if and when I have to. So here's the IF amplifier tube, the IF transformer, and coming in here to the detector. Now if you go back to this tube, look at these two tubes are the same tube, EAF42. They've used the same tube, IF amplifier and the detector first audio here. They look a little different inside because they've chosen to draw them a little bit different. It's the same tube. And look what's down here. There's a detector. There's a detector halfway through the IF. What are they doing with it? Looks like the DC voltage is being, whoops, wrong wire, is being sent back, up. I'm going to guess it's controlling the bias on the first tube. So using this tube to control the bias on the first tube. Is it controlling the bias to itself? Can it do that? I don't know. It sounds like an oscillator to me. But so moving on. So here's the real detector tube. Here's the detected signal right in here, coming through here. There's the volume control right there, and then the signal's fed back up to the, I was going to say triode. It's not a triode though, and on over to the output tube and on its way to the out of here. I noticed down here there's a lot of resistors with electrolytic bypass capacitors on them. All these electrolytic, oops, this might not be electrolytic, but this one is. All these are, can be questioned at this point, including these two big guys. I could turn this radio on and it might just hum and do nothing more. So as with all European, German type of radios, the engineers are very free with the components. There's a lot of components in here. I think if you presented this radio to a North American company building radios at the same time, they would look at this and the first thing they would say is, I can make this radio work with half as many parts. It might not work as well, but it would work well enough. And I think that's kind of the difference between when you look at a European radio versus a North American radio. The European radio, the engineers were going to town on it. And North American radio, the business people were going to town on it. Make it cheap so we can sell many, many, many. So we're ready to turn this guy on. Is there anything more we need to look at? There's all these notes in German with exclamation marks after them. Look at this one down here. Look out! So I tried reading these. I'm hopeless with German. Hopeless. 42 watts. So, oh look, there's somebody's signature down here. They don't have a title block though. 6/6/50. So this is June 6th, 1950. This guy, he either drew it or he signed off. This could be the engineer responsible for this. And someone else may have drawn it. They may have worked on it quite a bit, and now he's happy he signed it off. 1950. 840 760D. So that sounds like a drawing number to me. The D, and I'm just guessing here, in my practice, my past experience, the D is a paper size. It's D-size paper. If it means the same thing in Germany, I have no idea. So, who knows? Is there anything else in here that's really... What's this up here? Construction... Verboten. Well, I just have no idea what these things are saying. But we did manage to find out what the... didn't we? Did we see the IF frequency in here somewhere? Didn't I see it? I thought I saw it. It's like 475. I don't see it now. Maybe it was on another piece of paper, because there's more information, a lot more information about this radio. All in German though. So for now, that's enough of looking at that. Let's go back and look at the radio and ponder plugging it in and turning it on. Okay, so why wouldn't we just plug this guy in and turn it on? I mean, I've got the restricted power system here. Why wouldn't we do that? to shine a little more light into the back of this radio for me. Ooh, what's that? What's this? Oh, it's been in here all these years. And there's no back on the radio. I don't have a back for it. It came without a back. Which is one of the reasons why I had some trouble identifying just what radio this is. The only information I have on it is the look of it, basically. And I managed to find a photograph which led me to the Meersburg W, I think, is the model name for this. I'm not sure because Meersburg shows up all over the place, so this might be Model W. And this pretty simple thing here, but there's no place to plug these in. Well, I don't know what this is all about. Hey, is there anything else in there? It's supposed to be a bar of gold, you know. I always hope to find a bar of gold in these radios. Frankly, it hasn't happened yet. Now, another thing about German or European radios is they're often built so most of the time you can service them without pulling them out of the chassis. So they often have a removable plate. I already know there is one on this radio. So if we kind of flip it upside down or sideways or anything else, we can get at the bottom, take a plate off, we can get most, if not all, the parts underneath the chassis. Here's this wild tuning deal here. Oh my gosh. It just looks enormously complicated. I'm not going to put the close-up on it yet. This is probably an IF, but here's another IF looking thing, and it's got two cans here. 8.50 it says on it. This could be the choke coil for the power supply, unless there's some secondary wires coming out of it. No, it looks like there's only two wires coming to this. So this would be the choke coil in the power supply. This is the output tube here. You can kind of tell because it's extra tall, it's extra big. And it's got a big tall tube up here. This must be the rectifier tube in the power supply. It's got some fuses here, probably high voltage fuses. So if there's a failure or short in the high voltage circuit, you pop this fuse instead of popping a resistor or something else inside the radio or a tube itself. You know, this is common again. This is another example of the engineers doing what an engineer would think is right and important. In North America, these fuses would never exist. Never. That'd be the first thing to delete. Delete off the design. I am going to get the close-up camera going because there's just too much weirdness, weird stuff in there. Now, maybe this will help me find the camera. Here it is, right here. It's right here. And boost up the lighting here a little bit. Oh, sorry, you're already looking through the close-up camera, which is, I'm going to leave it focused really tight. Okay, so out of focus. You see what I'm looking at is the tuning system with two big wheels. This one here, you know, I got this on too tight of focus. I'm gonna have to fix it. So this one is hooked up to the knob at the side. So when you turn the knob, you're turning this one. Let me just fix the focus here because it's way too close. Bear with me momentarily. Bear with me even longer momentarily. Okay, here we go. Now we're going to focus back. Something like that. That's a lot better. Hey, what's this stuff here? Oh. Well, if this is the power supply, part of the power supply, well, a couple things. One, they didn't want it to leak like this. leak like this over a long period of time, or if it runs hot. If it runs hot, hotter than intended, hotter than engineered, then that might indicate problems in the radio drawing too much current out of the power supply. Okay? Who knows? This probably doesn't mean much of anything, really. There's no build-up down here. It just ended right here. It's not a lot of stuff. Could also be from an event. Something could have happened at one time, and whatever was that maybe overheated this is gone now. Something to keep an eye on, though. Well, actually, keep a finger on. Here's this weird thing, by the way. This is just the coolest looking thing. It looks like wire in there. Maybe it's just a coil. It's got an adjustment on it. Cool colors. They could have made that out of another color. It would not be so cool. What's going on with those tubes? That's the tube base. The tube base rises up to hold the tube. Are they all like that? Yeah, they are. So again, this is another thing that would be deleted immediately in a North American radio. The engineers would be saying, but the tube could shake loose. Yeah, we'll never sell it. It's a competitive thing, you know. Phillips tube. Oh yeah, so we wanted to look at the tuning deal here. What is all this mechanism? I mean, usually it's just, you know, a string and a couple of pulleys and direct drive. What is all this stuff here? Oh my gosh, what's this thing doing up here? Okay, so I'm going to tune the wheel. You can see it turning. I bet you this is like a friction drive in here. Yeah, I think that's what that is. So when you reach the end of the run, it just slips. Let's reach the end of the run. There we are. So I'm at the end now. You can see I can still spin the handle. I think my Hammerland radio has friction drive also. So then that's actually driving the shaft into the capacitor there. The result here is really heavy gearing. I mean, I'm turning this wheel out here quite a bit, right? But the capacitor is barely moving. It feels fantastic too. See this big wheel, the weight in it? It's a big flywheel. Lets me do this. Fun. So what's with the spring-loaded arm? Oh. So there's also this wire here. So maybe this is the same. This wire is the same wire that's holding the pointer. I think that's what that is. Just like the last radio I did, it's using a wire here. Oh, there's the tension spring, pulled pretty good. And I get a little dark back in there. How do they gear it onto here though? They must have a set of pulleys back there. Yeah, so there's a one pulley. Oh, the wire's pretty kinked up. Look at that. Was it hanging on by a strand there? Yikes, how did it ever get kinked up like that? And can't quite. Let me get some more light in there. This is way down in behind. Well, I can see the wire coming to the right. How did he do that? How did he change direction? It's going over the top and then coming out the front. It's going down also. Well, there's some trick going on. Oh, there's the other wheel. So they actually have this arranged so that the wire turns a corner. I'm trying to decide if it's two wires or a single wire turning the corner. Oh, look at that bracket. Is that bracket cracked? Yikes! What is that? That looks cracked. You know, I'll put it. Wow, it's a big piece of metal. either cracked when they first put it in here. Let me tune the radio and see. Can you still see it? Can't really see it. I got my hand in front of the... Wait a minute. Let's see if I can swing this around this way. Where'd that bracket go with the crack? I've lost it. Okay. So I want to see if that, when I tune it, if that pulley is wiggling. The bracket is wiggling around it. Oh, I don't see anything like that. What's that? What's that sound? Something rubbing somewhere. Let's go right to the limit and put a little more tension on the spring here. See if my radio's cracking away. Holy smokes, it's a long ways. There we are. I've reached the end now. You know, the slip drive slips so easily that I'm not putting extra tension on the string. That would be one of the reasons why it slips. So you don't get to the end of the run and then tense up the string to the point where you break it. Well, I'm not going to worry about that bracket because what can I do about that? But I noticed they put paint on these screws to lock everything in place. It's really quite the... Look at that. Really, I'm sure if again, North American, not knocking European engineering, understand this, okay, but if a North American engineer brought this design forward, I think he'd be laughed. Laughed out of the room. Why don't you just hook the knob straight to the capacitor? What do you need all this stuff for? Hey, what's all this down here? So this is the back of a switch at the front. What is the switch? That's the something switch. So I think there's a tone switch. I think that's what I'm switching now. Sorry it's in the dark there. Just put the light over here, Jim. Come on. Oh, what's that weird? What is this? Is that? What's with the spring-loaded copper thing there? It's clearly a switch. Maybe when I get this in some position, the switch is activated. Let's go all the way here. Maybe that's the on-off switch. Okay, so that's one limit. It sure looks. Okay, so can you see the contacts? Can't imagine this is the on-off switch. Okay, do those contacts move? It's right at the bottom of the screen now we're looking. Wait a minute, did I pull this knob? Hey, it doesn't seem to go back together. It pulled it and it seems to be locked now. I don't want to push anything too hard. I just broke this radio. No. They aren't really coming together, are they? Oh, this just doesn't feel right at all. I would have been better off not knowing I was supposed to pull on that knob. There's the knob. It's just gone flimsy, like it's not doing anything. Like this part's still doing stuff, but this ain't out. Uh-oh. It's a pretty light wires coming to it, so I can't imagine this is the power switch. Yeah, definitely something happened to it. Okay, well, we know that now. That's why I do this kind of poking around, so I make sure I know what I'm doing. Actually, the best I can do is make sure I think I know what I'm doing. At the point, hey, here's some truth in life that I learned. I'm happy to share with anybody. It has to do with investigations, just like troubleshooting is an investigation. But this is true of any investigation. Medical investigation, police investigation, any kind of investigation. The investigation does not end when the truth is known. The investigation ends when the investigator is satisfied. That's when they end. Now, maybe the truth is known at that point, but maybe not. So when I'm doing this kind of work, every time I get satisfied that I know something, in the back of my mind I'm saying, no you don't, no you don't, no you don't. And frankly, the back of my mind seems to be pretty smart. It seems to be right all the time. Now what are we looking at here? So we're looking at, what are we looking at? Oh, this must be an adjustment here. Oh yeah. Sorry, I wasn't looking in the camera. So that's an adjustment. It's right in the antenna area, so it's got to be an antenna adjustment. They've located these coils outside of the main structure of the chassis. See, they kind of tacked it on. So, in fact, it's all, I'm going to say it's tacked on as part of this complicated tuning thing up here. But no, I don't think so. So, my guess, wild guess, totally wild guess. They wanted to add these coils after the fact of designing the radio, and so they bolted them onto the outside. They made more cabinet basically and bolted them on here. Just making that up? I have no clue what's really going on. I have no clue. What else can we look at? So there's a few adjustments here. I can't go fooling around with all the adjustments in here until I've improved my German. Uh-oh. Now what are these things here? 14F6, 8.5. Well, they look like coil cans. So I can imagine there's a coil inside there. This top part, I can't see how that's an adjustment. So if we look at these, these are clearly, adjustable coils. They got to be the IF transformers, but look at them all in here. And this goes back to that set of coils that I don't really know what they are, that are in between the mixer tube and 470. Oh, that's a good hint right there. 472 kilohertz. Does this one say the same thing? Of course not. 44U something. 40, I don't know what that is. Well, we could guess, especially if that tube turns out to be the IF tube. We could guess. These are the two IF transformers here. And these are these front end guys that I don't know what's going on with them. And they're up near, kind of near the front of the radio. But that's the antenna input, so they're right in the right place. Oh look, there's more of this stuff. How did I get there? Is it this stuff? This stuff coming out, I can see this just dripping out the bottom and running down. That's easy to figure out. How would it get up on here? So this may be an indication of much more serious problems with this guy. Overheating. What, did you just spit the stuff out, or did it throw it up? I don't know what that is. There's absolutely, there's just a roof of the cabinet with some spider webs. There's nothing up above this, so I don't know. Could this have happened? Well, it's a wild guess again. The radio's out of the cabinet, turned on its side, somebody's working on it, and goop is leaking out of this thing while he's working on it. That's my somewhat ridiculous guess. Let's take a look at the power supply last. Here it is. So you can look at these fuses I mentioned were probably high voltage. Now that one says 220, 125. So those notes may or may not be referring to this fuse. Here's the setting, 125. I would guess the top is the proper setting. 120 milliamp fuse. So this is almost certainly a high voltage fuse. You know, they put the rectifier tube up here. They're generating the high voltage right in this area here, so why not put a fuse there? This is the oh, look at that. I had no idea that was going to come off like that. Funny little ground piece sneaking out there. Wow. A lot of these European or German radios, the power supply is kind of bolted onto the side of the chassis, like this one. It probably means they're built modularly in the factory, and then the modules are brought together. They put some pretty heavy hose on top of these wires. You can guess those are high voltage wires. And let's take a look at the speaker, last thing. Oh, it's in English. Higher fidelity. R&A. Wolverhampton, England. 1950. So type flex transformer. 780p. 12,000 Gauss. I've never seen stuff like, oh, it's the 780p Mark III. Somebody was pretty proud of this speaker. There's the connections. It's obviously a permanent magnet speaker, and only connections for the voice coil. And then go down. Where are they going? I know. I happen to know. I see where they're going. They're going down here, and they're going to the plug. Oh, that plug is almost. Hey, the plug is sticking out. What's going on there? One second. Wow, that feels as solid as can be. Now it's got 3 prongs with only 2 wired up. That's okay. So, but it looks like it should go in another ½ inch almost, but not going to happen. Well, okay. So this review doesn't reveal any reason I should be scared to plug it in. Again, because I have some restriction, and I can tell immediately if there's a serious short circuit in the radio. This piece of wire is obviously not original. This could have been me. No, I don't think so. I don't think I did any of this. Because we don't have the back, or I don't have the back, I cannot read on the back what each of these things are. But I think we can be pretty sure. Hello, Peanut. Yeah, you know what? He's upset because he's seen the weather report. The weather report today is snow starting soon, carrying on till about 2 in the afternoon, then rain for a couple hours, and then back to snow for the rest of the evening. So we might end up with a foot of snow with a layer of water in the middle of it. Oh, Peanut, you know what? Peanut, I'm just about to turn on this radio. Peanut, where are you? Where are you? Oh, there you are. Peanut, I'm going to be turning on this radio. Do you want to stay here for that? No? Or what would you like? See how he turned towards the door a little bit there. That's his way of saying. That's his way of saying I'm bored with this whole deal. Before I bore you, I'm excited about turning this guy on now. We're going to do it with well, we'll do it with this antenna, assuming this is plugged in right. So we put this loop of useless wire here. Okay, excitement's building. Just make sure this is done. It's not done correctly, but it looks okay. I'm not going to redo it. It's my radio. I can kill myself if I want to. Actually, you really can't kill yourself, can you? Well, you're not supposed to, are you? Okay, back it up. Now, front controls, or controls in general. So somewhere, oh yeah, I was going to show you this. So watch through the little window here, and we're going to bring in the close-up camera because there's something I need to see here too. That's the band indicator here. So flipping it around, good close look at it there. You got a shot of me in the background too. How's that for cool? Let me focus this up. Okay, see, the camera's a little low. See if I can raise it up here just enough to make it. What's really happening is the words in the window are falling a little low, like they're not aligned properly. So I'm gonna change it, the band set. Oh boy. See, that's not quite blank. Can you see 29 in there? And this is 16 to 36. 16 to 30, 36? 29, 36. And now, see, it's just gone so low. If I tip this up and look down, you can see UKW, which I think indicates FM. But, oh, peanut, please. Now we're going to go back up. 1630. What's that in the middle? M. Meters. Okay, so this should be sitting up like this. 1630 meters. 16 to 30 meters. That's something about this radio. 29 to 32 meters. It doesn't give a frequency range. It gives it in meters. But this now, this is in kilohertz. Obviously, that's the regular AM band. I'm going to have to go and deal with it. This is below the AM band. It's 150 kilohertz to 400 kilohertz. I guess that was a big deal in Europe. Doesn't mean much over here. Well, never meant much over here, I don't think. What is that? Okay, so that's the corporate symbol for Quebec Hydro. That looks like an on-off switch. So that might be off. Off, low, medium, high, higher, UKW. I had no indication in the schematic that there was any way to get FM with this radio. I didn't see any detector for FM or anything, but then, who am I? So we'll assume this is off, and we'll apply power in this mode. But first, I'm gonna have to stop. Now, you don't have to stop because the video, of course, when I come back, it'll be just fine. You know what I'm talking about? I don't. I gotta stop here and go deal with my poor cat. Okay, gave my cat a little bit of affection he was looking for. Maybe he'll be happy now. Or we'll go find our other cat and they'll go off and play. That's what I hope they'll do. So, we're plugged in. I think the switch is off. We're going to apply the power here. You can't see the lights, but I can. Here, but in case it's exciting. See that light bulb back there? Keep your eye on it. Perfect. Nothing happened. Perfect. So I think off is off. So we'll now flip this on and see what happens. Here we go. I don't think anything at all happened. So one of the things I'm looking at, which you can't quite see, actually it's impossible for you to see it here. This meter here, which indicates the voltage at the end of the outlet, shows that there's full voltage there. I've got the dim light bulbs in there. There should not be full voltage. So that means this thing is not drawing anything. So this is not the on-off switch. Must be the Quebec Power Company symbol. So where are they hiding the on-off switch on here? Well, it may be in this one. But this is the, oh no. This is probably the on-off switch here. I probably shouldn't be pumping it like that either. It looked to me like, and this would be backwards, when it was in, those contacts were closed. Really, this is what it's going to come down to. Broken on-off switch. Let us consult the schematic briefly here. There's the on-off switch. So this must be the incoming power. It's a double pole switch. You know, this thing was only pushing two contacts, so this is somewhere else. Of course, it's not going to say on here where it is exactly. Somebody help me find the on-off switch. I'm sure it's this. And I could push those contacts together. I could read the voltage. I could read the voltage on them. I could read the voltage at the top of those. But those are going together. When I push this, they don't actually touch, do they? Wait a minute. Son of a gun. Nervous. Oh, Peanut, please. Okay, so we're on a regular band, so this has to be in the on position if this is in fact the on-off switch. Power cord's coming over here, so you kind of expect the switch to be over here, you know, to run power wires all the way across the radio. So where's the switch? There's no switch. Well, we're off to a big bad start here. Let's do a couple things. Is there any power making it to the radio? Or are these fuses blown already? They look good, but first of all, is the power making it to the radio? I'm watching carefully while I do this in case while I'm pulling it off the radio comes on. 121 volts, so the power is here. Wow, this is nothing going in there. Okay, let's just look across these fuses just in case, but they sure look good. That's a 0. This other one I suspected was a high voltage one, but I don't think there's any high voltage in here. Or we're going to get nothing of any use to think about. Blown rectifier tube? I don't think so. I think we get a little bit of a current draw because the transformer would still be hooked up here. Broken on-off switch, it has to be. Well, there you go. Okay, so I'm going to take a little break here. I ponder what I want to do about making this radio work at all. This is really not where I wanted to get to, but you know, this is what happens when you start working on an old radio. It's just about everything under the sun could have gone wrong with it. Okay, let me go rest up and get ready for the next round here. Okay, so I've given it a bit of thought, and I think I have to utter the words that everybody hated to hear back in the 60s or 70s when the repairman was looking at their TV or their radio. Jim, it's got to go to the shop. So I'm going to take it out of its case, and we're going to get a better look at it. See if I can figure out how to overcome the on-off switch. Okay. Hey, good news. So despite the fact that my cat is meowing at me, I made a great discovery. See, I'm putting this knob back on. I started taking the knobs off to, of course, take the chassis out. Need a bit of a different screwdriver here. On quick. Some good news is coming. Whoa, Where's that screw going? I missed it. Got more problems here. So I turned the screw right past the threads and now it's stuck in there. Okay. I'm too excited to worry about that. Here's what I discovered while I was undoing this. I went to pull the knob off and there's the on-off switch over here. What this is, I'm not sure. I just haven't turned the set on yet. Okay, so back in business. We're back in business. I'll just leave this off. We'll set this to the regular AM radio band. Wow, I learned how to turn this on and off. Isn't that something? Okay, so we're going to put on the power. And we are going to pull the switch to keep your eye on that light bulb back there. Here we go. Perfect. Okay, so the voltmeter up here dropped, which you couldn't see, but I could see. But see those lights? They didn't come on, did they? So what's going on with this radio? That should have caused those lights to come on pretty bright. And it's working. Son of a gun. Wow. Boy, I came close to doing a lot of unnecessary work there. Whoa. Just what I'm trying to avoid. Great. So again, for an antenna. Oh yeah. Okay, so this is the antenna. Good, I can extend it if I want. Let's just try with this. Just put the camera here like that. No magic eye happening. So we're still on restricted power, but the radio is drawing, you know what, it's getting 115 volts. See, the radio draws almost no power. Let's go tuning. No lights on the front. So the tuning indicator is here, going this way. Now, what frequency are we on here? Hey, where'd this go? 600, 500, 700. So right in this area is where we should get stations. I cannot see the pointer. Oh yeah, I can see the point. It's just really hard to see without the light. Oh, Peanut, please, man. Well, it appears to be receiving, just not receiving anything worth hearing yet. So, let's go back. It's not picking up too much noise either. 600, 640. So we're right in the range where we should get something. What if this is so out of whack that I'm not on this band? I'm actually on a... No, it sounds like the AM band. Okay, so I'm going to put my loop antenna on this guy. I guess it just would be between here and the chassis. There's no... Oh, what's this up here? These don't seem to be hooked up to anything. Well, isn't that odd? That they would include some plugs. This is a typical antenna input plug for German radios. They have a two-pronger that goes in there. FM ready. Maybe this is part of it being FM ready. So what was I going to look for? I was going to do something here. I can't remember what I was going to do. I was going to look at the schematic for some reason. Oh yeah, how's the antenna done? The antenna comes... Look at that. UKW dipole. You can't look at that. UKW dipole. So that's FM dipole. Where's it going? I don't know. Just a couple of arrows. This is the one we're interested in. This antenna, single terminal. It's got to be this. Through a little resonant circuit of some sort. Down, down, down. Another quad. Down, down, down. Oh, so it looks like it ends with another plug. Probably this one here. Oh, yeah, there's one there. Okay, that answers the question. My loop antenna will go right in here. And where is that loop antenna? I have to go get it. So I'll get it set up and we'll carry on with the better antenna. Okay, let's hook up my good friend Mr. Loop Antenna. First I have a little jack here. I can. That was me as the antenna. We don't want me. Now, looking at the schematic, the ground connection is right to the chassis. Is that the chassis? I know for sure that that is the chassis and not a wire running through the inside of the radio. I don't see any suggestion or indication that it isn't the chassis. How's that? So we'll start with that. So we'll put this, because it's easier to clip this on right onto the chassis. And the other side here we go. How do you like that, eh? Now this is liable to fall off here as I turn the radio. Still having a postal strike. Beautiful.
And John Copeland with Adobe Analytics says, much like Black Friday, they project Cyber Monday will better last year's numbers.
This radio's working beautiful. Beautifully.
Anywhere from 7.8 to nearly $8 billion in online shopping. And if that's the case, it would represent a 24%.
Yeah, so what's happening in Canada now is the federal government is getting ready to legislate the post office back to work and cut their strike off, and this is a big problem because it's it flies in the face of freedom and freedom to associate, all those kinds of things. So it's a big deal here. It's taken quite seriously, but at the same time, it's the postal service for all of Canada. It's falling way behind. So there you are. The usual conflicts that occur, I guess, in all countries happens here too. Well, let's try shortwave. Yeah, let's try a shortwave band here. Oh no, let's go right through this AM band because this is working really well.
Follow us on Facebook and Twitter or get the free Radio Player Canada app. In sports, after losing in the CFL the last 2 years, Calgary Stampeders
can't find the pointer again.
Grey Cup champions. The Stamps beating Ottawa 27-16 yesterday in the 106th Grey Cup. Stamps had lost the previous two, and head coach Dave Dickinson says the win is a big one, especially for City.
Okay, it's really hard to see. It's right here now.
I think we know we're down a little bit now, and we're looking to something to show people
something
we're proud of
temporary.
It's their first championship since 2014.
Oh, son of a gun. Throw it in the bag.
Thanks to win number 17 on the season last night, a 125-115 win over Miami. And fresh off a 6-0 pounding over the Flyers on Saturday, Leafs welcome Boston to Scotiabank Arena tonight. It'll be their third game in 4 nights. And for all your sports,
a little better.
Log on,
I still can't see it over here, though.
Having a look at the forecast.
Oh, forecast.
Through the day, getting to a high of 5 degrees. Mainly cloudy tonight, to low of 1. Tomorrow, rain mixed with some light flurries, a high of 3 degrees.
So that weather report's for Toronto, which is about 100 miles south of me. And it's not necessarily valid for where I am. So I gotta adjust my antenna tuning here. Sounds great. Oh, so this is the tone control. this again? I missed it. Oh yeah, right, can't back this screw out. Okay, let's put on this knob now, finally. That was a lot of time. The reason I got in trouble was I didn't have the knob pushed in far enough, and the screw went past the end of the shaft and right out. Okay, now we're going to find out what that knob does. Let me find somebody talking. Tune my antenna. Oh, incidentally, the big news in Canada is that General Motors has decided to stop its operations in the city of Oshawa. It's right near Toronto, where General Motors has been building cars for 100 years at a plant that once, this is a story all over the world, I guess, at a plant that once employed 30,000 people, currently employs about 2,500, and they're just closing it down. And why? All the auto manufacturers have seen the light. They know what the future is. The future is little electric cars. That's the future. No use making gas-powered cars anymore, because that's not the future. That's what's going on. So that's a big upsetting thing in Canada. It is only 2,500 jobs. It really shouldn't be completely freaked out about it, but the symbology of heavy industry packing it in is a little hard to take. That's what's going on in Canada today. So apparently that announcement may have been made, or it's going to be made later today, official announcement by General Motors. So General Motors, the Oshawa plant is one of the original General Motors plants. So it's a lot of history there. Okay, let's tune this radio now. Oh, we're going to turn this knob. Tone. So here we got treble, no bass. Treble, more bass. Not sure what the difference was there. Less treble. A lot less treble. So it's just all tone. Kind of like that. Still no magic eye. No magic in the eye. Or is there? Yeah, we can see it with the close-up with the other camera. If there's any eye in there. Well, the blue light is from the camera itself. There's no light, no red light from the heater, nothing. So I don't know. Looks like a bad day for the magic eye. Of course, I'm just tuning out of the range of the antenna, which is why the radio's gone quiet. Let's put it on short wave. We gotta see what's going on here. Let me just grab a wire or two. Now, the front panel is calibrated in meters, which is really never been popular in North America. So I'm not even all that familiar with it. But I studied the meter conversion table, so I know what the range is. And there's two shortwave bands written in meters here, but the actual frequency is 6.1 to, I can't remember, and then I can't remember up to 17. So I think it's 9. I think it's somewhere at 9 in here with the two bands in terms of frequency. So it's good. That means it's got good coverage. It just take off the venerable loop antenna and replace it with the problematic wire antenna here. That's problematic. Holy jumper. Was that really an antenna I just plugged this radio into? What did I plug it into? Man alive. That's just the worst ever. I hear my poor cat crying the whole time. Come on in. Come on in. You know, it's winter, right? Poor cats. Well, okay, let's flip the shortwave. Maybe we won't hear all that crazy noise. Okay. Yeah. Yeah. Right. Crazy noise? Much less. Grounding? Oh, see, I didn't get it really grounded the first time, I think. Yeah. So, we're going to leave it like this. See what we get. Where are we? What band are we on? Boy, I don't know. So we're just gonna, let's just rip along here. Pretty consistent. Consistent Maloney. Next band. I don't know if we're testing the radio or testing my antenna. So I have to run and make sure the antenna is switched on into the shop here. So I'm going to do that. Yes, it is. So let's put the ground on and see what happens. Pretty quiet. Forget which controls what. Come on. Did I reach the end of the road already and don't know it? I can't find the point. There it is. I can see it down here better.
It says, if you abide in me,
Okay, so I'm not sure why it's so noisy like that. But there we go.
I believe that our prayers will be more effective if His Word is abiding in us. In fact, I find sometimes in prayer in the mornings in my office that my prayer life is...
This prayer life. Yeah, it's very easy to go right past the station.
hard on prayer and on...
Faith not yet.
There he is.
He moved with fear for 100 years. To prepare an ark, a safe place.
Brother Stare. Wrong time of day, not the best antenna arrangement here. Okay, so let's review the situation here. Volume is up pretty high to hear that. AM working really quite well. Magic Eye not happening. Words have disappeared off the band control, but you have to look really close to see what band you're on in some cases. Perhaps that's because I've left it like this for years and light has come through and destroyed the print. I don't know. I was really excited yesterday when I first grabbed this because there were some indications that it had FM in it. I thought, whoa, I'll have a lot of fun with this. Turns out I don't think there's any FM in here. What it means by FM ready, I think it's a baloney. This switch is not working, or is it? We don't know. Oh. Well, I don't know what this is doing. Could be something like turning on and off the automatic volume control. But it sounds like it's working because I hear a pop every time. Wow, I really almost got myself into a real jackpot trying to fix something that's not even broken. So there we go. Oh, another thing would be the grill cloth here, because so much dirt has formed where the speaker is. And you know, that's from the speaker operating, and a combination of pulling the air back and forth through it, and also just over the years, air can drift through here, but it can't drift through here. There's a board under there. So this just filtering out the dirt in my house. That's what that is. That's my dirt up there. Actually, this is a what would you call this? This is an integration of dirt over time. So through this dirt, you could examine the history of this radio somehow. I don't know how, but very good. Wow. Okay, so you know what? I don't think I'm going to do any more of this radio. I'd be crazy. Magic Eye doesn't work. Well, too bad. I don't want to get in there, and it's, you know, it's buried. The chassis has to come out to get at that. So I think I'm going to be happy with it as it is, and say I've got a nice SABA radio. I'll put it back on the bench. We'll see in 20 years. I'll turn it on again. That's if I'm still on. Okay, so thanks so much for watching, and I gotta dig something else out here.